Okay. Um, just give me a second. Okay, so I think you can all see me, right? And okay. Yeah, so if you can hear me, just turn on your mic and then just speak to me so that I can confirm that you're all with me. Yeah. Kingsley, are you there? Oh, okay. Great. Okay, good. So, um, last time we did introduction, right? And today we are going to start with the theoretical background. Okay, this is this training syllabus. We have the first thing is theoretical background. There we're going to be talking about what streaming is, what live streaming is, what is compression, encoding, what's decoding, what are streaming protocols, what is CDN. We're going to be talking about the theoretical background because this is very important for us to, troubleshoot when we have issues with our live stream. Live streaming is just once you start your live streaming, probably once you start streaming to YouTube, you don't really have anything to do. It's the platform just take hold of the transmission and all that. But there are some things you need to do, and those things are really major on your theoretical background because you monitoring your streaming is not just you looking at how pastor's mouth is moving or how the images is changing from one position or the other. It's more than that, right? So I mean today's lecture, that's what we're going to be considering. We're going to be looking into details about the theoretical aspect of live streaming. And the second part is the hardware aspect. The last time I told you there are three paths to live streaming. The first one is the hardware, the second one is the software, and the third one is you yourself, and then the theoretical knowledge that you have and the application. So we are going to be probably the third week. We're going to be talking about the hardware. That's from Tuesday. I think we are going to use 2 days, Tuesday and Saturday. Then for the software aspect, that's the following week. We're going to talk about the software aspect. Then we're going to talk more detailed about vMix and also OBS. And the last week we're going to do some practical. That's some workshop. So let's jump into our business of the day, which is the theoretical aspect. So the first question I would like to ask is what is streaming? Streaming first. I know many of us really like we've heard a lot about streaming, and most of us we actually do stream, okay? But I'm sure we don't really know what it entails. Like you can go to probably a website, probably YouTube, and you try to stream one of your favorite comedian, right? So and you laugh, you just when the network is bad, you try to change your network and wait for it to buffer, right? But we don't really know the what it really means, like you streaming. So in the early days, right, the first websites were simple pages of just text and probably maybe with one or two images. So when you go to a website, probably um, CNN.com, what you see is news headline, and they show you some pictures, right? So that's the early days of the internet. But today, what you see is video content together with the text, together with images and all that. Okay, so anyone with fast enough internet connection can watch high definition movies and even make video calls over the internet. This is possible because of the technology called streaming. Okay, so streaming is by definition is the continuous transmission of data, and into bracket audio or video file, from a server to a client. Okay, so there are three things to take note of in this definition: data, and then server, and the last one is client. Okay, so when you have data moving from point A to point B, we call that transmission. And an aspect of transmission or communication, right? The aspect of communication that deals with audio file and video file, moving audio and video file from one position to another. And the first position is the server, and the second position is the client. That technology is known as streaming. Okay, so in a simpler, just a simpler term, streaming is what happens when probably consumer watch TV or listen to podcast on the that's yeah on their internet connected devices. Okay, so from the diagram here, you can see that you have server, and in the middle you have data, and towards my right you have the client. And the client looks like probably your laptop, your smart devices, your IPTV, and your TV, your smart TV, and all that, on any other device that you can use to watch probably any video or audio content. Okay, but I know what you don't really know much about is the server aspect, and I've already talked about the data, which is your audio and video. During the course of this course, we are going to share more light on what this data is. Okay, so streaming is so now let's go to the second question, which is what's the difference between streaming and downloading? Difference between streaming and downloading, right? So streaming is real time, while downloading saves copy of the entire file on your device storage. Okay, so when you're streaming directly from a server, right? And it is real time. You don't have to copy that same file on your hard drive. But when you download, right, you can, when you're downloading, you're not getting that video content real time. You are saving a copy of that content from wherever server you're downloading from, and this file has to finish downloading on your local system or your local device first before you watch it. Okay, so the next thing I would like to talk about here, let me see, that's the next slide, is okay, so how does streaming work? So just like data that you sent over the internet, audio and video data, they are broken down into packets. Okay, and each of these packets contains a smaller pieces of the file, and the audio, it contains the audio and the video, right? Then your video player in the browser on the client device then takes the flow of that data packets and then interpret them as video or audio. So this might sound somehow to you, right? But that is just what's, and all these things happen just within milliseconds, less than a second. But in your mind, I just need you to just picture this thing and slow it down as possible. So when you have a video file on a server, right, and there's a device elsewhere who is trying to access that particular file, what happens is that server, there are protocols, there are processes that the server, you are trying to request, you place a request to the server by going to the website. Probably you go to youtube.com. The internet carries that request to the server, and the server will respond with whatever video you want to watch, right? But within that few seconds, right, what really transpire is the server itself look at the request, fetch the video file that you want to watch, then break it down into pieces, like, because it can't really transmit that video file all at once over the internet, right? And also the video file, the real video file is not what is being transmitted over the internet. So it breaks the video file into segments, compress it, encode it into ones and zeros, then transmit it in in bit by bit, right? So over the channel, that probably over the internet, right? We're still going to go into what protocol does it use to transport the data. So it's transported from the server then to your client. So at the client end, your browser has this it's so intelligent in such a way that it reads the data that was sent, right? It uncompress it, arrange it, and then decode it. Then you can see whatever video you're requesting for, right? All these things happens within like milliseconds. Like you can't even, it's beyond what you can see, or just it happens like very fast. Okay, so the next thing we're going to talk about is, does streaming use the user, that's UDP or TCP? So UDP is user datagram protocol, and TCP is transmission control protocol. Yeah, that's a very good question, and probably some of us we will have. Can we all hear me? Okay, good. So we might have seen. Okay, correct. So we might have seen this term probably when we are trying to do our research on probably streaming and all that. UDP. These are IT terms, and if you are into networking, then you should really know about what UDP is and what TCP is. But I'm going to like give you some brief overview of what UDP and TCP is. So um, to a very probably to some extent, you know what server is, right? Server is where all your files, like the file you want to watch, the video file you want to stream, where they reside, they are stored there. The client is your end device. This is your phone, your laptop, right? Your browser, most especially the browser on your laptop, the browser on your phone, because that's the particular application that interface with the server. Not even your phone, is the browser on, because when you want to access any content online, you go through your browser, right? Or you go through the application installed on your phone. So the client we're talking about here is either your browser or the application that you use to stream, like you used to watch video from, let's say YouTube app, right? So, but for the data aspect of it, and you can see the tunnel, right, from the image you're seeing on my slide, the channel. So that's what we really want to talk about now. So some streaming method uses UDP, which is user datagram protocol, and some uses TCP, which is transmission control protocol. So UDP and TCP are transport protocols. So they are the protocols you use to transfer that data, that's audio and video file, from the server to the client. They are the carrier, just like you entering, like you're at Lekki and you're trying to go to Bagada. You need to use a channel. You need to use probably Uber or bus, right? Or bike. So what carries you from, for example, here you are the data. So what carries you from Lekki to Bagada is what we call the transport protocol. Okay, so let me break it down. Let me talk about, let me just tell you what TCP is. TCP is um it opens a dedicated connection before transmitting data, and it ensures that all data packets arrive in order, unlike UDP. So but UDP does doesn't even consider all if you get to your destination. So let's just use a practical example. Let's say Ben wants to, after MLP, Ben wants to go to Bagada, probably to stream or to do one or two things, right? And Ben tried to, like, go to the bus stop and enter a public bus. When you enter a public bus, the driver doesn't even care if you just tell the driver this is where you are going to Bagada, right? He doesn't care if you get to the place uh, on time. He has to, like, branch some other places and pick up some other people, right? So his allegiance is not to you alone. You understand? But for TCP, it's just like Ben ordering Uber, and with Uber app you can really monitor where your position at any point in time, right? So it's more secured, and it ensures that Ben gets to Bagada, right? But for UDP doesn't care about, what it cares about is just you just, when you get to your bus stop, you stop, right? There's no flow control, there is no uh, you know probably there's no other features like that ensures that that packet, that data you are sending, gets to the destination. Okay, so um so the difference is now, when it comes to streaming between TCP and UDP, is that UDP can, is faster when it comes to delivery, because it's just, what it cares about is just you getting to your destination. And if you drop on the road, it doesn't is not if some of the packet drops on the road, is none of his concern, right? But wherever gets to the destination, gets to the destination, right? But for TCP, if the packet you send, that's the data you send from the server, if some of it does not get to the client, it has to retransmit those packets again. You understand? So every file that you send from the server, right, must get to the client. If it doesn't get to the client, it will retransmit them back to the, you understand, to the client. That's for TCP. It ensures guaranteed delivery of whatever you send, right, at the client end. But for UDP, it doesn't ensure that. Once you send the data on the road, probably there are some attenuation or some packet drop, probably the internet is not good. Wherever packet gets to the destination is what you receive. And it's really, like, really best for, these two protocols as their use case, right? For UDP, it's really best for voice over IP, for live streaming, because it doesn't make sense when pastor says, um, hello, topic for today is going to be righteousness. That's what is transmitted from the server, right? But when you get to the client, what you get is, hello, righteousness, topic for today. Like, the reason for that is because probably between the server and the client, there was probably issues with the internet, right? and some packet got dropped. So you were able to get the first packet, which is hello, and the last packet, which is righteousness. So when it gets to the client will say, because there's this there are some so it has a tag that ensures that whatever is sent from the server gets to the client. So when it checks that tag and notice that some of the packets are missing, it will send back to the server that please send me this particular file because I didn't get it. Probably it might have gotten dropped by probably the internet or some issues. So it will send. That's why you're not getting the other data that you didn't receive earlier. So it doesn't really make sense when the client, as a user, for you to be getting all that kind of uh, stuff. So, but UDP, whatever drops. So if it's hello righteousness that you get, then you will be able to decode that from your own head that okay, yeah, probably the topic is talking about is righteousness and all that, right? So it is very fast, and that's why it's mostly used for live streaming and also for voice over IP. Okay, so the next thing we are going to talk about, okay, is buffering. So okay, so when you are streaming, right, with your media player, you can see the image on my slide. You see current position in video. You see buffer that's already loaded content and not yet loaded. You see this most of the time when you are streaming, and um, this is actually intentional. It's a way to ensure that you get all your content, like whatever you're trying to stream, you get it like all like there's reliable transmission of what you're trying to receive, right? What you're trying to request from the server. So streaming media player loads a few seconds of the stream ahead of time so that the video or audio can continue playing. So if the connection is briefly interrupted, like you have bad network, right? So this process is what we call buffering. So it loads some of your content beforehand, you know, so that you don't get stuck when you are trying to request or a particular particular packet and probably your internet get dropped. You understand? So it loads before you watch that particular video so that you'll be able to get a smooth stream. Okay, so you see this most of the time when you are streaming video. So at some point when your network goes down, you notice that the green stuff will stop where the gray that's where the buffer ends. Then you notice that yeah, there's no internet again. But it's not just that the internet just stopped working, right? It has actually stopped working, but you were able to continue playing the video because it has a buffer. Like it has, yeah, it has buffer probably for some seconds. It has loaded some of your content ahead of time. You understand? So, and this is really cool when you have unstable network. But when you don't have network at all, it will surely you will surely be cut off from your streaming server. But when you don't have a reliable connection, anytime there is network, it loads the content, and whenever your internet goes down, it stops, and when it comes up again, it loads it. So it helps you. It's just like a way of ensuring that you have a smooth stream, and it's actually a good thing. Um, so next thing we're going to talk about here is live streaming. We've talked about streaming, you know, um, but we need to talk about live streaming and what is the difference. What's the difference between streaming, you know, and live streaming? From what we said earlier, streaming is the method of data transmission used when someone watches video on the internet, right? Is a way of is a way to deliver a video file just little by bit at a time, often from a remote storage location. So the video file that you are streaming has already been stored in a server, right? It's so you're just getting the video as like a video on demand. You understand? So you're getting the video from you are getting the video from the server. So but live streaming is when the streamed video is sent over the internet in real time. So you don't so the video you are watching is not already stored. You are directly watching like at this point you don't really have a server, like a storage server where the video is being stored. So what you're looking here is the production server. As you're generating the video, as you're generating the audio, someone is elsewhere trying to like watch that particular video. That is what live streaming is. So it is real time. You don't store the video file in a storage, probably a storage system. You are streaming directly. So you think about the difference between the regular streaming and live streaming as the difference between an actor reciting a script and an actor trying to like improvise, like talk real time. There's no script, he's just talking from his head. You understand? So content is created beforehand. That's for streaming. You create your content, your video is recorded and it's created and stored in a server beforehand. Why the other, the audience receives the content in the same moment you are creating it. So I think we understand what the difference between streaming and live streaming. Okay, so the term live streaming is usually refers to broadcast like one to many connection, like you are producing a content at a particular location and so many people all over the world are watching. That's one to many connection. So this goes out to multiple user at once, and we can see different uh, platforms that really does that. uh, Platforms like YouTube, your content is streamed to YouTube, and wherever you are, like you can watch the content, live stream like the content from YouTube. Same thing as Facebook Live, Twitch, Instagram, right? So that is live streaming, and I would just like to know if we, at this point, if you have any question as regards streaming and live streaming. If you have any question, you can just probably chat, put a chat on the chat box, or you can enable your mic and then probably ask your question. If you have any question at this point, any question, any question. So we all understand what streaming is and what live streaming is, right? So I can call names and then probably ask question. So I'm looking at Daniel Idim. So I don't know if you can just on your HUD or your video. Let me get to see your face. Let's get to see your face. Daniel Idim. Are you on the call? Then Samuel. Is Samuel on the call? Can you all hear me? Hello? Okay, so Daniel, are you on the call? Is that Daniel responding? So Daniel is not actively on this call. It's also Samuel. Um, Alex, Alexandra, Alex, are you on the call? I'm not sure he is too. AZ, 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 is AZ on the call? Okay, public transport. Okay. So, uh, no Benjamin is on the call. Um, okay, Ben, can you on your video? If let's see your face. Oh, okay. Okay. So, I think AZ is here with us. Okay, so I would just like to know if you understand what streaming is and what live streaming is, the difference between streaming and live streaming. And I would just want you to probably in one or two sentences just give clarification between streaming and then live streaming. Oh, okay, okay. Okay, so is it Iphie? Iphie? Are you on the call? Yeah, can you talk to me? Um, Tell me about what streaming, what you now understand by streaming and live streaming, the difference between the two. Yeah, good morning. So I didn't get the last part, live streaming part. Okay. So in real time, like the moment is you're producing the video, you're getting that video elsewhere. Like yes, though that there'll be some delay though, like but you know, yes, depending on your encoder and decoder. Okay. So and uh let me see. Ben. I need you to talk to me about. I think Kinsley is asking a question. I need to talk to me about the data. That's we have server and then we have clients. Then we have data in between. So your data is your audio and the video file, right? So this data on the group, right? I mean, there's a question on the chat, right? I think I saw that, Kinsley. Yeah, Kinsley. So my question is, when we are streaming and it's breaking, is it the network or that's the problem? Is it the network or any other thing that can cause that? Yeah. So a lot of things can can cause that? Well, majorly network, but we are still going to that, right? So, but a lot of things can cause that, but most of the time is network. Okay, we are still going to talk about that. So back to um, Benjamin, Ben. So I just needed to just in your own word from what you've gathered so far, what um, the transmission protocol, you know, used by your data, you know, to getting your data from the server to the client. We talk about TCP, we talk about UDP. So just in your own time, just give us the differences between the two, what's the two, like what TCP is, what UDP is, and what you understand by the differences, and the use case. Okay, so we talked about the server, we talked about your client. We said the server is where your video is stored. Now we're talking about streaming, where your video is stored. Yeah. So, and then the client is the browser on your client device, right? That you get the end, you get the video, like you watch the video from. Then the data itself is your video and your audio, right? So you're moving that data from the server to the client side. I will talk about the transmission protocol, transport protocol. Yeah, so we talk about TCP, we talk about UDP, right? So these two are really are in use and they have different use case. Okay. So and I need to just tell me what TCP is in your own understanding, and then what UDP is, and then the differences between the two. Control protocol. Protocol. Okay. Datagram. Okay. 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 So you know, applying it to streaming now, you know your data can you have different data when you're moving data from one position to another. That's communication, and that's probably even um, when you're browsing, what you're actually doing is you're sending data from your phone, like the request. Now you're sending data from your phone to a server. When you go to www.google.com, right? You as a client, you are typing this on your browser, on your phone browser, which is your client. That's a client device. You understand? You are putting up a request to that google.com is a server. It's a file on Google on Google server, right? So you are placing a request to that server. So if you resolve that address www.google.com, it resolves to an IP address which is on a server, right? So that server gets that information, then send you what you are requesting, the web page you are requesting, it send it back to you. So everything on the internet is like a client to server relationship. You understand? And the form of data that you are requesting for, when you try to go to probably google.com, that is not is not an audio or video file or data, right? It's probably a text, right? But when Google is sending you, probably to send you with video, so it sends with audio and video file, so that if on the web page there is an embedded video, you understand? So what it sends, the response it sends to you includes the audio, video file, the text file, but all these things are really like converted to like a digital form, ones and zeros, which we're still going to talk about, right? So yeah, TCP UDP is used generally on the internet. It's a transmission a transport protocol, and it's yes, so, and it's also used when streaming, because streaming is a form of communication over the internet, right? So TCP TCP it's reliable. So when you need a reliable transmission of your video file and audio files to the client, then you use it uses TCP. You're not you're yeah, it uses TCP. But when you don't really need reliability, you need your data to get there very fast, right? You need your data to get there at in a real time, because streaming does not really like it doesn't care about what it cares is the reality of like you getting those files in real time, you understand? Because in TCP, once the data you send from the server gets to the client, and probably not all gets to the client, it won't deliver the stuff to you. You know, there are some mechanism in place that it will allow you to get that file at that particular time. It will retransmit, right? It will request for the lost file until when it gets the lost file before it transmits to the client. And that is the reason why you have so much delay in when you are streaming. Yes, you understand. So it ensures that all the files you are sending are being received by the client, right? Which doesn't really make sense when you have a one-on-one communication on the phone with someone, right? It's expected that or you are interviewing someone from probably you did probably a Skype connection, or as we are doing Zoom call. So just imagine me saying something now and you are hearing it after like 1 minute or 2 minutes. It doesn't really, and I'm expecting you to talk back to me. You understand? If you are using TCP, then that's the case. But UDP, you know, that the protocol your Zoom platform is using is UDP. So that's why you can really hear me. Once there's break in network, you notice that you won't hear part of what I'm saying, right? Cool. So that's just the differences between the two and their use case. Um, who else? Who else? Okay. 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 So yeah, of course, that shows that the client doesn't not really knows about. So that's the reason why we are talking about the theoretical aspect of things, so that you have something to tell the client. So and so far from what we've talked about, you still have something you have something to tell the client. You can tell the client this is a live streaming um, uh, scenario, right? And you're using, because between you're streaming to YouTube. YouTube uses um YouTube uses RTMP. You use when you're streaming to YouTube, you enter the RTMP address, right? The stream key, the stream key and the stream URL is an RTMP. You notice that when you're putting the stream URL, it starts with RTMP. RTMP is a TCP connection, right? And it ensures that whatever you are sending gets to the server, because you are streaming to YouTube server, okay? From your vmix you are streaming to YouTube server. That's why if you want to stream to YouTube, you go to YouTube Studio and you get two details. These two details are the stream key and the stream URL. The stream URL is the address of the server of YouTube server, right? And the stream key is just like form of authentication, just to ensure that you are the one sending, not someone else is sending to the server. Okay, so every account has its own stream key. You understand? So these two information, two stuffs is what you input on your vMix when you are streaming. Okay, so and one thing you notice is the HARTMP is a TCP connection, right? It ensures that wherever you are streaming from YouTube gets to the YouTube server. Okay, and if there is delay, like there's this 20-30 seconds delay, because the way it's configured is it gives a a buffer size, so that wherever you are sending, irrespective of the internet connection, the stability of your internet connection, it gets to YouTube server. Okay, so once it gets to the server, and remember I told you those packets are being sent bit by bit. So once you get the first batch, YouTube server inspects and confirm that these packets are complete, right, before sending it out to to your client, that's to whoever is watching. So there's this delay, which is what you notice, right? But if you are beginning to notice more than like expected delay, then there is something else. And if you notice, if you are conversant with live streaming on YouTube, you can select low latency, you can select normal latency, and there's this other third thing you can, and all has different time. You can select normal latency, low latency, and ultra low latency. And I just need you to take note of it. If you can just start, we can just practicalize this on our own, right? I think this will be our first assignment. First assignment, yes. So I need you to open a YouTube. If you don't have a YouTube channel, I need you to open a YouTube channel, because it's a prerequisite for you to test your live stream and at least study what streaming to YouTube is all about, right? Open a YouTube channel, and under the stream latency, right, try to stream using normal latency, and then try to stream using low latency, and also try to stream using ultra low latency. One thing you will observe using low latency is using normal latency is that it will be breaking. If there is internet, you lose some details, right? I just need you to observe what you get, and then probably um, at a probably demo class, then we'll talk about it. So just take note of that. That's the first assignment. You stream using normal latency, low latency, and then ultra low latency. So all this so what I'm trying to say in essence is all um, these three uh, options for you to stream to YouTube, they are all there just to ensure that when you stream using normal latency, the time your client gets the stream is elongated. Like if you're using low latency, you get about 20 seconds. If you are using normal latency, you get about 1 minute. Okay, if you are using ultra low latency, you get something less than 20 seconds, like 10 seconds to get the stream. But when you're using ultra low latency, you notice that there is this break, because it's trying to, like, what you're telling YouTube is, don't worry about the packet delivery. What I need, what I actually need more is the real time. That I just need this video to get to my client like as soon as possible. So don't put your all these you know, features that ensures that all this your what you're sending gets, that guarantee the successful delivery of your packet, right? So what you can tell the client is, this is the default based on the fact that you are doing live streaming, right? and you are using TCP, you might not understand what TCP is, but just try to explain in your own word, right? That is normal for a live stream, to have this particular um, seconds of latency. Okay, so I hope this answers your question. But if it is more than that, then there is something else, and I think during the course of this course, um, we'll share more light on that. Are you okay with that? Okay. Okay. So our assignments are, after we open the YouTube channel, how do we get to stream in this different latency? I'm not sure everyone will know how to get to go about this yet, sir. Okay, so I just need us to take note of that, and for some of us that really know how to go about that, then cool, right? Um, because for you to do that, you need OBS or YouTube, and yeah. So we all have local church, like people from Ikeja. I'm sure you use Vmix. People from Bagada, I'm sure you use Vmix too. So probably you can just do a test. Yeah, just try a test probably after service. You can just go to the control room and then probably meet anybody who is in charge of streaming, and then just try and run the test. And so we are still going to do it during our demo session too. So I just want us to take note of that. I didn't plan, it just came up. So yeah, that's one thing to note. Yeah, so AZ, I think AZ wants to ask a question. So, okay. Okay, yeah. Okay, so what we used then was so you stream from a software to YouTube. So we use Vmix, right? We use Vmix because there's no way you can stream to YouTube only if you want to use the YouTube app. So you have two options to stream to YouTube. It's either you use the YouTube application, that's the YouTube Live, or you use third-party application, which is probably vMix and OBS or Wirecast or any other application, right? So now you use vMix to stream to YouTube. Streaming to YouTube is when you select any of these three streaming latency: normal latency, low latency, or ultra low latency, right? So you streaming to YouTube takes about, let's say, let's say five let's say 5 to 10 seconds, right? So YouTube now send, like, if you're now watching from your phone or from your browser, so you're not streaming directly from the source, you are streaming directly from YouTube server, right? So that on its own too add another latency of about 10 seconds when you choose low latency. So altogether, when you are now monitoring when you are streaming from the source and when your client is getting the stream, then you are looking at roughly 20 seconds. So the default, if you want to have a good live stream, is the low latency option, right? It's the low latency option. But if you go through ultra low latency, yes, that ultra low latency we give you like more it will be more real time, like lesser latency, right? But the guarantee of you having good stream is low, because it's what you're just trying to say is don't worry about the delivery of the data. You understand? You are confident that your network is good and everything is like, provided everything is equal, your network is good, you don't have any issue, then you can use the ultra low latency. But bet me, like, just trust me, Nigerian network will surely, they have it has its own issues on its own. So it's better you use, so when want to have a smooth streaming, you have you have to use the low latency. If you use normal latency, that one is even worse. So I just need you to observe the difference, right? I need you to observe the difference. So what we used then was sorry. Okay, you have to stop. It's grayed out when you start streaming. That option is grayed out. Yeah. Okay, so now we go to the last, I think it's the last part of today's. So how does live streaming work? So I think we really have some question as regards this topic, but yeah, I think we can talk about it now. So how does live streaming work? You remember, live streaming is real-time delivery of your video file to your clients in real time. Like, so live streaming actually starts with video capture, right? So you capture your raw data, that's the video and audio, by probably your camera or your capture card, right? Within the computer device to which the camera is attached. So the virtual information is represented as digital data, in other words, ones and zeros in deep level. So, but we have different class for the video capturing. As we're going to talk about this when we are talking about hardwares, right? Okay, so the first thing I would like to talk about here is the segmentation. Video includes a lot of digital information, which is why it takes longer to download a video file than to download a short PDF. When you are downloading a short PDF, even if the PDF is about, let's say, 500 MB, it's faster to download compared to when you're downloading a video file which is about even 200 MB. I don't know if you've noticed that, but you can check that out. So because it will not be practical to send all the video file or the video data out over the internet at once. So streaming video is divided into smaller segments, a few seconds in length. So what happens, and this happens at the server end. So when you have your video, and this is also applicable to um, streaming, when you have that's VOD, video on demand, or live streaming, when you have your video on the server. So when you are requesting, when your client is requesting for your live stream or requesting for your video on that resides on the server, either probably YouTube server, Facebook server, or your personal server that you have your uh, video on your, yeah, probably your media server. The first process it goes through is segmentation. It doesn't send all the file at once, right? It divides it into chunks, into chunks, bit by bit, right? So once it divides that, then it goes to the stage called compression and encoding. So the compression is, so the segmented video data is compressed and encoded. The data is compressed by removing redundant visual information, and this will really shock you. So let's say you have a frame like you're seeing me right now, and the frame is about 1920 by 1080, which is the standard landscape frame, right? Each pixel has its own address. Uh, am I communicating? I just need you to understand. So um, so this contains 1920 by 1 by 1080 pixel, right? It's just like matrix. So each box, each pixel has its own address. Okay. So what happened is during compression, the first frame of the video, it analyze it and register all the address of each ones in bits, ones and zeros, right? So as it is now, I'll be talking for about 1 hour, and what really changes is probably my movement and the slides. So there are some of the pixel, you know, they are arranged horizontally and vertically, right? So some of them has not even changed since I started this broadcast, right? So what the compression does is just the reason for this is just to reduce the size of the video file. So what it does is it will just register, it will register the first frame and the address, right? So subsequently whatever changes, it will register the changes, not the whole frame. It will register what changes. You understand? So it's just like telling, it's just like a mathematical calculation, right? So that at the other end, when you're trying to uncompress the video file, it just read the mathematical expression that okay, the first frame is like this is the address, it arranges that, then the next frame for uh, pixel 1, it doesn't change, it remain the same. Pixel 2 remain the same. Pixel 3 changes from this to this. It doesn't send the whole video, it just sends like file, like code, one and zeros. And that is what compression is. And it will shock you that the compression format, so it all depends on your encoder, because both compression and encoding happens on like simultaneously, like the same time. You can also call compression encoding, but they have some some differences, right? So I know you might not be able to get a very clear picture of what this compression is, but I need you to understand that it doesn't send all the audio and video file like you transporting yourself from a place from probably Lekki to Bagada, like, you understand? So instead of doing that, it registers the first frame and register the addresses of all the pixels, and for pixels that does not have change during the course of the video, it remains the same. Like, it just puts constant 0, it doesn't change, right? For the pixels that changes during the course of the video, it registers that okay, this changes to this. It just so it just write the information. It's not even sending the file, the video file itself. It's pull down the informations, right? So, and all this happens at the server side. So think of video compression as being like adding a piece of new furniture to a living room. It's not necessary to buy entirely new furniture. Each time a new chair or side table is added. Let's say you furnished your room, and probably you went to a place and you probably see another chair, or probably a chair. So because you want to buy a new chair now, just one chair, you now want to change all the furnitures in your room. You understand? So it's not really wise. You understand? So that's just what like compression is. So it's what it does is it's instead of it's possible to keep the room layout roughly the same and change as just one piece at a time. Occasionally make large rearrangements as necessary. So similarly, not every frame of a video stream needs to be rendered in total. Just the parts that change from frame to frame, such as movement of a person's mouth. So encoding now refers to the process of converting data into new formats. So live streaming video data is encoded into an interpretable digital format that is widely that's that a wide variety of device recognize. Common video encoding standards uses H.265. So the encoding aspect of it, after the video has been compressed, during the compression is just like encoding. Encoding is just converting your video and audio file into ones and zeros. So what goes through the channel, you remember the transport protocol, what goes through your TCP and UDP protocol is their bits. They are the encoded video and audio file, and they are in ones and zeros. So it's not the actual video file that passes through the channel, right? The transport protocol. So, and this um, the common encoding standard is the H.265, which is widely used. We also have H.26, that's H.264. Then the new one is H.265. That really compresses more and still retain the quality of your video file, right? All this happens on the server. Okay, so now going to the CDN and caching aspect. The CDN is like a content delivery network, and what this means is once your live stream has been segmented, compressed, and encoded, so all of which only takes a few seconds. So like I said, all these things, like the processes is milliseconds, like it's not even up to a second, right? But you just have to slow it down in your mind and like try to for you to understand. So it needs to be made available to like dozens or millions of viewers who wants to watch it. So in order to maintain high quality with minimal latency while serving the stream to multiple viewers in different locations, a CDN should distribute it, and that's where you have your YouTube. So you're not streaming directly from your vMix, from your location, from vMix to your client. You understand? You are streaming. So let's say logically that's not how it works, but to you, you might feel like, yeah, once you start streaming, the clients are seeing it. Like it's a you feel it's just a straight line between you and your clients, one to many, one to your different viewers. No, logically, from your system, from your vMix system to YouTube server, if you're streaming on Facebook to your Facebook server, streaming on Instagram to Instagram server, then from Instagram server goes to your clients, right? And for the Instagram server, we might have up to like 10 or 100 of Instagram server, and that is called caching. So once you stream to one, so YouTube has servers everywhere. Like they have in Africa, they have server in Africa, they have server in US, in Europe, right? They have their server everywhere. In Nigeria, they do some co-location with some ISP. When I used to work with CobraNet, they have we have Facebook server, and yeah, there's a server reserved for Facebook, right? So Facebook pay them every like quarterly or yearly or something. So the reason for this is just to cache. So if you are trying to access, the main server is probably in US, right? But they now have just for them to serve you to reduce the latency between you, because when you're communicating from your phone, you are trying to connect to US, right? So to reduce the latency between Nigeria network connecting to US, what they do is they co-locate their server with probably an internet service provider or a data center in probably in Lagos, in Nigeria, right? So once you are trying to fetch any, so they synchronize all those the main server with with the server in Nigeria, the based on what content you are fetching. You understand? So once you try to go to Facebook, you won't go directly to the US server. You might go directly to US server in the first instance, but subsequent communication will cache that particular information, because when you are getting it to send to the Nigerian server, and then the Nigerian server will send to you. So the subsequent communication will now be between yourself and the Nigerian server, Facebook server. I think you understand what I'm trying to say, right? So just to reduce the latency between, like, just to speed up the rate at which you get your response, right? You notice that the first time you go to, I need you to observe this. The first time you go to a website, I need you to just clear up the cache on your browser, right? The cookies and cache on your browser. So go to YouTube or Facebook.com. The first time you go to YouTube or Facebook.com, it takes some seconds before it loads. But subsequently, when you close that browser and open it again, and you try to go to uh, Facebook.com, it loads faster than the first instance. The reason is because it has already cached. So there are different level of caching. It has already cached that particular website on your browser. So it's also uses your browser as your phone as for caching. And also there's a server in Nigeria or any network close to you, right? So that you fetch that particular content from, instead of going directly to the main server in US. And that is exactly what CDN and caching is all about, right? So you can as well stream from your vMix to your client, but you don't have that resources to do that, because you have multiple people connecting. If it's a one-on-one communication, right? Like Lekki trying to communicate with Bagada Church. Yes, from the scenario that AZ gave the other time. So you are trying to just stream a particular content to Bagada, right? You're trying to stream to Bagada. Sorry. So you are trying to stream to Bagada, and you are now streaming to YouTube. That's not a good idea, right? Because you consider the latency, because you are introducing much more latency. You're streaming to YouTube, then stream to then you use your probably on vMix, you get the content from your browser. So the latency, so it's better you stream from Lekki directly to Bagada. You understand? And there are some technology in place that does that. vMix has that, and there are also other technology that you can use to stream just directly from a location to another location. You understand? But in the case whereby you have multiple people streaming, you want to stream to multiple people, like multiple audience. So it's not wise for you to use your local system, like stream from your local system, and thousands of people are connecting to your system, because it requires the bandwidth. So what that means is you need to have a very good internet on your system, because each stream from each person, because everyone are requesting from your system, from your local system. And imagine one stream takes 1 Mbps, and you are streaming to about 10,000 or devices. So you can calculate the amount of data that you need. And whereas for you to stream a full HD content, you need about 3 to 4 Mbps. So now multiply that times 10,000 clients. You understand? So that is the reason why you have to stream to YouTube. So these are CDNs. They are content delivery network, right? They've built their servers, like they are rich to the extent that they have servers everywhere, and their servers are mostly in the cloud. And in the cloud you have abundance of network. You understand? So that's why about 10,000, 30,000 people can stream that same content on YouTube, and you are getting the same quality. Help you understand that? So but for you to do that on your local system, you even the system that you're using itself, you understand, it has to be able to build to accommodate the bandwidth, because there is network bandwidth, there is system bandwidth. So which is practically impossible for you to do, right? But for you to just stream to just one particular location, you can do that from your system instead of to that particular remote system without going through um, YouTube. Because if you go through YouTube, you are introducing latency, right? Okay, so I think I'm able to explain what CDN is and what caching is. So caching, YouTube has servers everywhere, right? It's not just one server. They have servers, and those servers are in the cloud, and some are physical, right? And they are co-located with most of these service providers. Okay, so wherever you are, if you're streaming, if you want to stream a content to, and if you notice, um, devices get that same content when they probably go to differently, like at different time. Probably you guys go to the same YouTube at the same time, but you the stream you're getting, right? Like there's probably 1 second's delay between devices, and all is because of the route. You know, the internet is full of like route, is full of routes, so it all depends on a lot of things actually. So, but what I need you to understand is the CDN and then the caching things, and I think I'm able to explain that. And if you have a question as regards that, you can ask. So for the decoding aspects, so the CDN now send the live stream out to all users who are watching the stream. Each user device receives, decodes, and decompress the segmented video data. Okay, so the decoding and the video playback all happens on your device, right? It happens on your browser. That's the, if you're using Chrome, right? If you're using Chrome, if you're using whatever device you're using, whatever device you're using, yeah. So okay, so it all happens on that browser. Okay, so the decoding is just you, like, you know, you're getting ones and zeros, so the decoder knows what those ones and zero represent, right? And it converts it back to the video file, and your video playback is what get that video file and then play it out to you, and you are seeing your live stream. So all this happens within seconds. Okay, so yeah, I think I'm done with this, and if you have any question, so if you have any question, you can ask. I think I have few minutes. If you have any question, you can ask as regards the segmentation, compression, encoding, CDN, caching, decoding, and video playback. I hope I've been able to communicate and try to make you to understand all these processes. Any question? Okay, I think no question. Okay, so I just want to say just two things. So you notice from this diagram, I'll just try to, if you look at the lower part of this diagram, you see RTMP, then you see SRT. Those are the two things that I really want to talk about. So these are streaming protocol. when you are streaming to YouTube, you use RTMP. Streaming to Facebook, you use RTMP because that is the protocol you use, you know, to stream your video from your local system to any CDN, to your maybe to YouTube server, to Facebook server. You use RTMP, and this RTMP uses TCP. Okay, so SRT uses both TCP and UDP. You understand? But you can't send SRT stream to YouTube. It doesn't support it. SRT stream, you can send SRT stream to server, from server to server, right? You can stream use SRT to stream from server to client. Okay, so RTMP, you use RTMP to stream server to server, and YouTube supports RTMP, Facebook supports RTMP, Instagram supports RTMP. Most of these public CDN support RTMP. Okay, so but